Just read the notes, and we're going to look at number 1. Okay, so we are going to graph by hand the f of x equals x to the 4th plus x to the 3rd minus 4x squared minus 4x. So you guys in your assignment for number 14 and 18, you will be graphing those two problems by hand. I might decide to add a few more on there, just because y'all are behaving so well today. Okay, but let's go over what the notes just told us before we start trying to graph it, okay? So first of all, the end behavior, we want to think about that before we try to graph this by hand, because then we'll kind of have an idea of what it's supposed to look like. So you want to look at your leading coefficient first. In this case, the leading coefficient is a positive 1. And it's positive, so that means the right side of the graph is going to go up. Okay, if it was a negative value, then that means the right side of the graph would go down. So anyway, so I know that it's going to go up. Then you want to look at the degree of the polynomial, which the degree is your highest exponent. In this case, the degree is even. So that means that the left side of the graph is going to go the same direction as the right side. If it was an odd degree, then that would mean that the left side is going to go the opposite direction of the right side. Okay, so in this case, it's even, so I know that both ends are going to go the same direction. They're both going to go up. Okay, I also can tell from the degree that this is going to have 4 zeros. Some of them might be real, some of them might be imaginary, but a total of 4. Okay. Also, I know that the number of turns is going to be 1 less than whatever the degree is. So in this case, I'm going to have, at most, 3 turns. Some of them might not be very big, so I might just have 2 turns or something like that, but at the most, I'm going to have 3. Okay, so I'm going to pick some points to plot on the graph. First one I'm going to pick. First value I'm going to pick for x is 0. So whenever x is 0, then your y value is just going to be whatever the constant is. So what is the constant going to be? 0. Yeah, the constant is 0. It's not, there's not 1, so it's 0. So that was an easy point to get. Okay, so then I want to do f of 1. I'm going to substitute a value of 1 in for the x. So for every x, I'm going to put 1. Okay, and that's going to work out to be -6. You should be getting a -6 in there. So that's one way that you can find the values of y when you want to graph by hand. Another way to do this is to use synthetic substitution, which we're not really going to learn, or we're not supposed to learn until a little bit later, but I think it's an easier way to find values. So I want to show you what that is. It's synthetic substitution, really. But the remainder that you get whenever you plug a value in for x is the y. So it matches and makes a point on your graph. Okay, so the way you do that is you just take whatever value for x, and that's what you're going to divide by. Okay, and then I'm going to put all my coefficients out there. I don't have any degrees being skipped, so I don't have to put any zeros in place, but I do need to put a 0 for the constant since it's not there. You bring down the first term. 1 times 1 is 1. And add those two together, so that's 2. 2 times 1 is 2. Add those together, that's -2. -2 times 1 is -2, and that's a -6. -6 times 1 is -6. That's your remainder. Okay, and that's what I got for my y. So it's whatever you prefer. If you would rather just plug it into the equation like I did the first time, that's fine. I really don't care which way you do it. I'm just giving you an option. Okay, so let's try another value. Now some of these, I've already done them several times today, so I'm going to give you some x values, and then I'll call on some people to see what you get for y. So let's do for x equals 2 and x equals 3, find out your y value for those two. Okay, so we got 0 when x is 2 and 60 when x is 3. So if you look at the values for y right now, when y is 0, that's where it's crossing the x-axis. So it's crossing the x-axis exactly at 2 and exactly at 1. Okay, but I could have 2 more zeros for your x. I could have 2 more times that it crosses the x-axis. Now since this 3 value, when x is 3, I get this huge y, I'm pretty certain that it means that it's just going to be going on to infinity. Okay, so I want to go the other direction with my x values. I want to go down into some negative numbers, so I'm going to give you a few more numbers to plug in. -1, -2, -3. And there's not a set limit on how many values you want to substitute in to find values for y. It's just however many it takes to get a good feel for what the graph is doing. Okay, so go ahead and find those values and then we'll see what you guys get. Okay, so we got 0, 0, and 30 for those values of x. So I got my other 2 zeros, my other 2 places where it's going to cross the x-axis, and this 30 is kind of telling me that that's the other place where it's going to start to go to infinity. Okay, so let's graph what we have so far. You guys need graph paper. If you don't have any out yet, go ahead and get some out real quick. Alright, so here's my graph. I kind of left some space on the x-axis. I made them kind of far apart because I have so many zeros that are close together. So I have a 0, 0, and 1, -6, 2, 0, 360. I'm just going to like put a little dot up there so I know that it's going to go on forever. Then -1, 0, -2, 0, and then -3, 30. So that's my other point where it starts going up. Okay, so you can see on this graph that I have 3 like right in a row, 3 places where it crosses the x-axis right in a row. So I want to figure out if it's just touching the x-axis there, if it's going to go through the x-axis. So I want to get some points in between. So what I'm going to do is I'm going to synthetically divide using -1/2 and -3/2. I'll just do it down here, and I'll do these because I know you guys really don't want to divide with the fractions, so I'll do it for you. You could double check me if you want, make sure I have the right answer. So we bring down the first term, that's -1/2, add those two. -17/4. That's -15/8. Okay, so when x is -1/2, I'm getting y is 15/16. Approximately, what is that with as a decimal or a whole number?
Almost 1.
Almost 1. So I'm going to put it like right here. Right about 1 on your graph. Okay, so now let's do it for -3/2. I'm running out of space. I'm going to have to write kind of small, sorry. So I'm going to bring down the 1. Okay, so for that one I'm getting -21/16 when x is -3/2. So as a decimal, that's about, I don't know, a little bit over -1, right? So -3/1, it's just a little bit past -1 for that.
1.3.
Okay, 1.3. So now I have some showing me where my turns are going to be, and I'm just going to use those to draw my graph, sketch it. Okay, and the arrows on the ends there tell me that it's going to go on and on forever. Okay, so in your book, let's just do On page 334, let's look at what you're supposed to find for 14 and 18. Part A says to graph each function by making a table of values. So this is what you need to have for Part A. Part B, determine the consecutive integer values of x between which each real zero is located. So for Part B, for this one that I just did, I have exact numbers where it crosses the x-axis. So if you have zeros for your y, it's not crossing in between, right? It's crossing right at that x value. So for this graph, your x values would be 0, 2, -1, and -2. That's where it's crossing the x-axis. Now, if instead of crossing right at the 2, let's just pretend like it crosses in between the graph, or in between two values. That's where you would say between 1 and 2, if it doesn't cross right at that point. Okay? Then on Part C it says, estimate the x-coordinates at which the relative max and relative min occur. So for this graph, you actually have two relative mins. Here's a relative min. That's a low point for your y. And here's another relative min. They call it relative because it's only for that area of the graph. It's not for the entire graph. It's just for that part. So to write your values, you're going to label it relative min, where x is about, and see, now you're talking about the x value because they want to know where it is on the graph, not what it is. They don't want to know what the y value is, just what x is. So this min occurs where x is about -3/2. And this relative min occurs where x is about 1. Okay, and then for your relative max, you only have one relative max on this graph, where x is about, here's your relative max, -1/2. So for your relative min, relative max, you're looking for your turning points, okay, where the graph is going one direction and then it turns and goes back the other direction.